Hello, welcome to this video 8-1. We are going to talk about radical functions and specifically today describing transformations of radical functions. Now we've had some exposure to this idea of transforming functions using parameters of a, b, or not b will be new for us today, and h and k, but we're going to look at that specifically for radical functions today, which is a new type of function. I want to go ahead and show you guys what a radical function would look like, and here is a square root function. And for sakes and purposes, I'll be specifically talking about square root functions. Radical functions also include cube root functions too, so you could see transformations of those functions as well, but really the only difference is that there would be a power of 3 right here in the radical for the index, okay? So today we're going to go ahead and look at some radical functions, and we're going to have these parameters that are going to be present in the function. So I want to recap with you an a value. If I change my a value, it can cause vertical dilation, specifically stretch and compression, or if a is negative, it also causes a reflection. So just recapping this, if your a value it's normally 1, right? You're multiplying by 1. If you multiply by a bigger value, that causes stretch. If you multiply by a value between 0 and 1, let's say by a half, it makes it compress to this x-axis. And then same with a negative value. So say it's negative 1, it's normal, we have a reflection. But if it's a value, absolute value bigger than 1, then we still get stretch, okay? So a value, stretch, compression, reflection. That's the main idea. Let's next talk about the k value. The k value tacked on at the end will move our graph up or down. Obviously, if k is positive, we're going up. K is negative, we are going down. Okay? So those are the factors that affect the vertical or the y values of a function. The x values are affected by these parameters, the b and the h. The h value you guys know as horizontal translation. Okay, if h is positive, we're going to the right. If h is negative, we're going to the left. But remember, it's always the opposite of what you see here. Okay, so you're supposed to see a negative in there. And then lastly, we'll talk today and introduce the b value. The b value parameter affects horizontal stretch and compression, and it will move it horizontally. Now, what you should know is that a b value that's bigger than 1 is going to cause horizontal stretch, okay, or sorry, horizontal compression. Do you see how it's getting tighter and tighter to that y-axis, this b value that you have here? And then if it is between 0 and 1, it's going to stretch it. And that's also because it does the opposite. And we'll look at an example here. Okay, so if your b value, what you see here is between 0 and 1, it's going to cause a horizontal stretch. And usually what we do is we take the reciprocal of this value. Also, your b value can be negative, and that causes a horizontal reflection. So we'll go ahead and look at those today. Okay, all right, so everything that I just kind of talked about is summarized here. It's very important to note that in your guys' graph here, it says a 1 over b. We'll always take the reciprocal of that value to get our b value. Okay, and then here's just some kind of diagrams of what I just showed you. So let's look at an example. Here's example number 1. What we're always going to do is we're going to identify our parameters that are given, okay? And so I'll add in a, b, h, and k. So here's our parameters. In this case, our a value is a -3, our b value is a 1, our h value is a 0. Notice I don't have anything b or h inside of that square root. So b is 1 because that multiplies. It's multiplying by 1. H value is 0. Your k value tacked on at the end over here, this is 5. Okay. So what are the effects on the graph? I want to describe this. So we're going to go ahead and say here, g of x has vertical reflection, vertical stretch, by a factor of 3, and a vertical translation 5 units up. Pretty straightforward. Nothing too new. Hopefully that seems really, really familiar for you. Now let's get to some of the wrinkles. In example 2, again, we're going to identify our parameters, A, B, H, and K. And again, I'm going to underline these items for you. Your A value is invisible. It's out here. It's an invisible 1. Your B value in this case is right here. I see a negative 1/2. I'm going to take the reciprocal of this. So your B value is a negative 2. It's always the opposite. It's always the opposite, and that's how you want to think with your H value. Here I see a plus 3, but remember, you always take the opposite. So H is a negative 3. And then our K value on the back is a 0. So here's your parameters. So just like in this last one, how I didn't have anything, visible, and I guess I could add in that B value. B value would be a 1, and then here we have like a plus 0 on the inside. Here's our B value, and then here's our H value. Okay, so both of them are inside, and remember, whatever's affecting the X is not always as it seems. So for your B value, you're going to take a reciprocal, and for your H value, you're going to take the opposite. So what are the effects? What are the effects? Well, G of X has a horizontal reflection I guess I should say a horizontal stretch by a factor of 2. Notice I don't include that negative. That negative just has to do with the reflection. Okay, so that the negative just tells me we're going to reflect. We have a horizontal stretch by a factor of 2 because we took the reciprocal. And then we have a horizontal translation, 3 units left. Okay, pretty straightforward. Nothing too crazy. All right. Next example. Here we have an A value that is 2/5, and we have an H value here that is 6. H is 6. What I don't have is I don't have a B value. There's an invisible 1. So if I don't have an A or a B, it's 1. If you don't have an H or a K, it's 0. So what are the effects that take place? Well, G of X has a vertical compression by a factor of 2/5. And, I don't want purple, green. And a horizontal translation (6 units right). Okay, A value is between 0 and 1, 2/5. That is between 0 and 1. That's going to be compression. All right, next example. On our next example, for this function, I see a B value. And that B value, remember, always take the reciprocal of B. 1/4. 1/4. And then it looks like we have a K value that is -1. -1. I do not have an H value. There's no H in there. And then my A value, again, is 1, since I don't have those. Okay, so what are the effects? Well, G of X has a B values affect horizontal. Horizontal. And since it's 1/4, it's going to be compression and K value affects vertical translation, and a vertical translation 1 unit down. Okay? Not too bad. All right, here are 2 practice problems. Please go ahead, pause the video. I want you to try these 2, and then I'll show the answers here in a moment. Okay, hopefully you pause the video. Here is practice problem 1. A value is 1, B value is -1/6. Did you flip it? You always got to take the reciprocal. The negative stays though. And then H value is a +1, K value is 0. The effects, G of X has a horizontal reflection that's from the negative and a horizontal compression by a factor of 1/6, and then a horizontal translation 1 unit right. Hopefully you did good. Okay, let's go ahead and look at the solution for the second practice problem. Okay, here's example 2. Your A value is -5/4 and your K value is -4, resulting in vertical reflection, which is also known as, maybe add this too in your notes, this is x-axis reflection. It reflects over the x-axis. For horizontal reflections, that's going to be y-axis reflection. This is y-axis reflection. And then we have a vertical translation 4 units down because our K value is negative. Okay, so hopefully you did well on those ones. Here are 2 practice ones. I'll flash at the end these answers and solutions, but I'm just going to go ahead and jump to this last example, and then we'll do this one last practice problem, and then I'll show you the solutions to those if you want. But I'm just trying to kind of condense time here. All right, G of X. In this example, we have a B value that is -1, and H value that is -2, and a K value that is -5. So what are the effects? And if you're wondering, A is a 1. But what are the effects? So we're going to say here G of X has a horizontal or a y-axis reflection, a translation 2 units left, and a translation 5 units down. Okay, pretty straightforward. All right. Oh, and then on this one too, there's no stretch or compression because your B value is 1. There's a negative, which just gives you reflection, but there's no stretch or compression because it's 1. Similar to the A value being 1. No stretch or compression. Okay, here's a practice problem. Please pause me, and then I'll talk through the solutions here in a second. All right. Hopefully you got an A value of 1. We don't have one in the front. It's there and it's invisible. Your B value is 5. That's the reciprocal of 1/5. Your H value is -2. Remember, it's always the opposite, just like your B value. And then your K value is 10. So we have a horizontal stretch by a factor of 5. We have a translation 2 units left and 10 units up. And that is it. Okay? All right, so just for your, if you wanted to look at these last 2 practice ones, here are the solutions. Okay, and here are the solutions. A equals 3/4. That's a vertical compression by a factor of 3/4, and then K is equal to a -4. That's a translation 4 units down. On practice problem 2, your B value is 3, causing a horizontal stretch by a factor of 3, and your H value is a +1, which means you are going 1 unit right. That's going to do it for this video. Go ahead, give me a thumbs up, a follow for more awesome math content. I'll catch you in the next video. Hope this helped. See you later.